I once again welcome you, all of you, the lecture series of electric power quality. So we are under fifth chapter now, distributed generation and power quality. How this distributed generating units will help to improve the power quality in the power systems. Now this is the actually 32 class, so regular class. Now we can go further class. Okay. Now see, we are in operating conflicts concept. So we are already discussed what are the different types of DC technologies. Okay, what is the DC? What are the different types of DCs available in the system, or how to connect these DCs to these systems, and all other things were already completed. So at the same time, how what are the problems we're facing these DCs? Nothing but voltage sags, harmonics, voltage regulations, all other things were already completed. Then what are the operating conflicts? What it mean by operating conflicts? Whenever you are connecting, okay, whenever you are connecting our DCs to the this side, this DC to this load side, yeah, this side. So what are the operating issues whether you connected this DCs to the distribution side and other things we are discussing in last three classes. Okay, we are concentrating because this is very much essential. As an electrical engineer, you need to know the what are the operating conflicts. So whether you simply connect the, yes, in our households also we are using solar plants, solar panels, and injecting the some power to the distribution lines. You are not bothering about the common people is not bothering about this operating conflicts. But as an electrical engineer, you need to know something about this one. What are the different operating conflicts? Uh, Suppose you are connecting this DC to this load side. So, which type of problems will create the DC and all other things? How this DC, how to protect these DCs from the external faults as well as internal faults and all the things we are discussing this operating conflict. So we are already completed the utility fault equipments reclosing and interference with the relaying as well as voltage regulation issues. We are very much thoroughly discussing this voltage regulation issues and harmonics. Now today class we are going to discuss the islanding problem, then ferroresonance as well as shunt capacitance interaction. So we are going to see this three topics now. Right. Now see this what is islanding problem. You know that what is islanding. So whether we are you can see this. As I said, this is a VS and sending in voltage. This is the we are receiving in voltage. Maybe this side preferable we are connected the DC. DC. Yes, we are connected the DC here. That may we have you should one thing you should remember, we are not at all consider which type of DC we are connected here. Remember, here in this operating conflicts, you just only see the whether you connected the DC to this feeder, then what are the different operating problems we may get into the system. Not that what type of DC we are going to connect. Solar, we are going to connect solar, or we are going to connect here wind turbines, or battery cells, or gas turbines, or plants. So many types of DCs we are going to connect here. So again, there is one other question is also there. By connecting DC is solar as well as wind is different cases differently, it will get some problems. Okay, by connecting here DC solar, by connecting solar here, it will produces some another type of the problems. At the same time, you are connecting here DC is a wind, it will produces some other different types of the problems. But you are not bothered about that one presently. You just only concentrating whether you are connecting DC, any type of DC, then what are the different problems you are facing. So what is islanding problem? Here islanding problem is very simple. Whenever you are connecting this DC here in this distribution side, where nothing but receiving inside and you are simply going to as a load side. For suppose, uh, as a protection engineer, as a protective way, in the last class we are already discussed in the inference with the relaying class. Here in this class, we are already here in this topic. We are already discussed here. Whenever, whenever you want to protect the a system, DC, as well as this feeder from the different type of the problems, feeder from the different private type of the problems or faults, you need to maintain the separate protective scheme for both. Wait, power cut is once again happen, but no problem. So yes, you need to protect the here. You need to protect the feeder separately at the same time, DJ separately. That means you need to maintain the separate protective schemes for both the feeders at the same time, DJs. So here this DZ protection. Yes, DZ protection, especially talking about this DZ protection. Now see this point, DZ protective relays will generally perform their function independently outside knowledge of the system to which they are connected. Okay, what is the main problem here? What is the main problem here? First, suppose what is the main worry about the protective engineer here? A protection engineer here. For suppose this DC relaying, yes, see this DC relaying, a DC relays will fail to detect the fault. Fail to detect the fault. Okay, so that will leads to the opening of the that will leads to the opening of the circuit breaker. So that means, for suppose this DC relay will fail to operate. What will happen if there is a fault in this feeder? This DC relaying will fail to operate. That fault current maybe goes to this DC will damages the system. Okay, in that means, but in that case, what will happen? This feeder relaying is open. This feeder relaying is open, but still, this DC is connected to this loads. That's loads. You can understand. You can understand here. So here the basic, very simple thing. Two different protective schemes here available. First one is feeder protective scheme to protect the feeders or distribution lines and all other things. What is the second case? A DC protective schemes is available to disconnect the DC from the any unwanted changes in the feeder. These are the two cases. Here our problem, islanding problem means here, if there is a fault in this feeder, there is a fault in this feeder. So the feeder relaying equipment's recloses and circuit breakers will detect that fault and clear the fault. Nothing but to open that fault. So circuit breakers are open. So that may be clear the fault. But in these situations also, DZ or DZ protective relays may fail to operate. What will happen here on that case? So this DC will not separated from this line. So this DC will not separated from this load. That may leads to the entire load voltage and load is driven by this drive by this DC. But actually speaking, this DC's capacity is not that much to drive this load. This is the alignment. That may lead to the sudden changes in the voltages to this load, a very low voltages to this load that leads to the voltage sag and may damage the system. At the same time, this DC is also damaged. You understand? So this fader is open. When the fault is occurred in the fader is open. But DC relaying failed to operate. That means DC is still continue to drive these loads. But DC capacity is not matching to these loads. Okay, so in voltage regulation, we will conduct the some different types of tests also. So a 5% test is conducted. This curve is conducted. You already observed this curve. If the DC capacity is below this 5%, you can accept it. Otherwise, will not accept it. So it is very much essential that the DC reading must detect the fault and to uh, clear the fault or to detach from this feeders. Otherwise, it may lead to the problem. Okay, this is the some islanding issues. So what are the solutions to this problem? How to whether the relays fail to operate? Yes, whether the relays fail to operate. Yes, how this islanding problem is occurred. Relays fail to operate. Relays fail to detect the external fault present in the feeder. So then, what are the solutions? What are the solutions here? So these are some different types of the solutions to the problem. So one way is the relaying. But you know that main thing is the relay. Another approach is, what is another approach? An anti-islanding is to make the requirement to operate the modes of the DC will interconnect that significantly reduces the chance that the generation will match the load when the inadvertent island forms. You see this? Okay, now? Yes, you understand this? You understand this? An anti-islanding. So this an anti-islanding approach. What is the solution here? An anti-islanding approach. What is anti-islanding approach? Where the connected DC maybe matches the load requirements. First one. And the second one, what is the second one approach here? So inverters operating in parallel less likely to form an islanding. So nothing but most of the DGs are connected in this system in parallel way that may leads to reduces the islanding properties. So then what is the next case here? So interconnected DG should operate in mode that does not attempt to regulate the voltage. That is the, and these are the three solutions to reduce this island. So next one you can see this some important topic, ferroresonance. Ferroresonance. You know that ferroresonance. You know that what is why this ferroresonance is occurred in the system. What is the ferroresonance? Whenever this resonance concept is coming, so mainly is occurred in the transformers. A transformers are nothing but the some inductive device. A resonance condition is occurred whenever you can keep in it mind. A resonance case is whenever you see that ferroresonance case, then you can keep in it in your mind. So an inductive element is present in that system. An inductive element, whether you are talking about the DC way, nothing but distributed generation way. So that is the a transformer. A transformer. This is the transformer. Okay, a transformer. Yes, see this transformer. So this is the very special kind of the resonance, which is inductive element is nonlinear characteristics of iron core device. Some different types of iron core in the laboratory also, measurements lab and all other things lab also. We are conducted the test on iron core inductor to detect that what is the percentage of inductance and capacitance. So this is the so this will happen when there is an inductive element. You know the transformer is an inductive device. So how this ferroresonance is occurred in the system? Yes, because of magnetizing reactance of transformer. So in series with the cable are power factor capacitance because of the magnetization of the transformer. When this transformer is magnetized in series with the cable, yes, this is a cable, or you have to improve the power factor by means you are connecting some capacitance by the load side. This may lead to the resonance case in the transformer. Okay, here you can see this figure 9.2 and 9.2. So you are consider two diagrams here. The cable, an underground cable. This is an underground cable. Okay, an underground cable. Yes, two cases here. Uh, so here you can see these two diagrams, 9.2 and as well as 9.2. Here, this is the underground cable. Remember, these are the underground cable. Underground cable. Okay. So here underground cable means here cable, you know that nowadays for transferring power, underground cable here a power cables. Remember, it is not the transmission cables. These are the power cables. These are the power cables. Nowadays in most of the cities to reduce the problem of external failure. So underground cables are most people using in most of the cities in India. So these underground cables, so at the substation they are connected to the, remember, at the substation they are connected to the transformer. For suppose you can so by using some codes that we can call it as a riser pole. Here you can observe that one. What is what is the riser pole means? So these are the underground cables. One, two, three underground cables are there. So these under in the substation, these underground cables are outside of that and connected to the that some pole. That pole you can call it as the riser pole. So through the fuse, they are connected through the fuse. See this fuse through the fuse. They are connected through the fuse. The pole is connected through this fuse. See this fuse, three fuses, three cables. For this is a three-phase system. For three cables, we are connected three fuses. So now this is the underground cable. It may form the cable capacitance also. So it may form the cable capacitance also. For suppose due to an external problem or an internal problem, short circuit problem, or external or external some means of some other problems. So for suppose any of the riser pole fuse is blows. Yes, see this here in this example, they can see the pole number 3 fuse is blown. This is separated from the system because of some additional part in this system. So this fuse is open. What will happen here? What will happen? Only this transformer is connected only to two lines. That means one and two cables only. Third cable is open due to because of some. So this is the case. See here, 1, 2, and 3. Now see this 3. 3 is open. 3 is open because of some external issues. Now what? Now can see the transformer connection here. Now can see the transformer connection. Now can see the transformer third is connected to the capacitance. Now see this capacitance. Now directly connected to this capacitance. Now see this grounding capacitance or cable capacitance. You can see this capacitance. That may leads to the rise of the some resonance in the some inductance in the system that will leads to the resonance. This is one of the case where resonance occurred in the system. Do you understand that? So this is the underground cable. That cable is buried out from the earth by using this rising pole. So due to some external fault, any one of these rising pole fuse is open or blown. So in this case, the transformer connection, you observe the transformer connection. You observe this transformer connection. You can see this transformer. One of the open cable, nothing but third phase is connected to the cable capacitance. Cable capacitance. So that may lead to the increase of the resistance in the transformer. So this is the one of the example here. In this case, a small example. They can talk here a very small example. Ferroresonance example. You can clearly observe this diagram. So this is the one of the transformer waveform here. So the transformer is connected in delta as a primary. Okay, the same case. So you see this delta as the primary case. This is the primary of the transformer. This is the secondary of the transformer. This is the primary. This is the secondary of the transformer. Yes, see this. This is the case. Okay. Now see this. Whether any one of the fuse is blown. That case. How that how this transformer voltage waveforms is appeared in this diagram. This is the time in this case. This is voltage we can measure in per unit values. That may be a 230 volts, that may be a 440 volts, 132 kV system, or whatever. Here in this case, a 130 kV system, a transformer here they can consider. Then what is the cable capacitance here? What is the cable capacitance? They can assume here 30 nano farads. So here this diagram is occurred. You see this model a case in which there is no load on the transformer and no arresters. There is no load on the transformer. There is no arresters. Here the secondary of the transformer is there is no here. They can consider some load here. You can assume that there is no load on the transformer in this case. Here this diagram or this waveform is drawn by using these conditions. So what? How this waveform? You see this waveform at zero, it goes to the negative value, nothing but a voltage sag case in this waveform. Yes, this leads to the voltage sag case at the voltage swell case. Remember voltage swell case at the same time voltage sag. Both the waves are present in this same way. The voltage sag as well as voltage swell. Voltage sag as well as voltage swell. Both the waveforms are present in this case. How this will get into the system? How this waveform is present in the system? So now see this. You can see this condition. High voltage and this wave shape are due to the transformer ramming in and out of the saturation. So this wave shape are due to the transformer slamming in and out of the saturation. Nothing but so when the fuse blown and off of the case, then on and off case of this circuit breakers, on and off case of this this fuse blown cases will leads to the what will happen when there is one of the phases open. Cable is nothing but this capacitance will give to given this some power. So once this open case, then capacitor on case. Once open case and capacitor on case, it leads to the some problem. Okay, so see this magnetic forces associated with this change causes the core to emit very loud noise that are sometimes described as the sound of large bucket of the core being sharpened or a chorus of hammers and anvils. So now you know that because of this resonance, you know that this is the transformer is the inductor. Because of this resonance problem, the transformer is getting some noise, a loud noise. So it gives it emits a very loud noise that can be compared in as some different way, whatever it may be. Our intention is to know that because of this case, ferroresonance case, how this ferroresonance is occurred in the system. If any one of the fuse is blown or any one of the this one is circuit breaker is open, on that case this delta side of the primary side of the transformer, one of the connection, one of the phase out of three phases, one of the phase is connected to the directly to this cable capacitance when this fuse is blown case. So that may leads to the resonance problem. So that because of that resonance, the transformer is giving some loud noise. Okay, so it will still maintain that maybe leads to damage the core of the transformer, but the inductive element of the transformer. So this is the one of the operating conflict while we are connecting these stages to the system. Then what are the another conflict here, the most important conflict here, the shunt capacitor interaction. Shunt capacitor interaction. Here this is our DC. Yeah, this is our DC. Yes, when you are at the yes DC, the capacitor bank is also the DC. You know that capacitor bank. Yeah, what are the DC? Different types of DCs are there. A solar, wind, gas turbine plants, and battery cells, and all other things are considered as DC. That size is less than 10 megawatt. You can consider as a DC. So here our DCs we can consider as a capacitor bank. The capacitor bank DC is the capacitor bank here. What are the different problems arising while we are connecting this DC? Yes, see this. Most of these DCs are connected to the transformer. Most of these DCs are connected to this transformer. Okay, so here we can assume that our DC is the capacitor. Okay, our distributed generating current is the capacitor. This is the sending in voltage. This is the receiving. Why this capacitor bank is connected to improve the power factor and so many things are happening. So many cases. So you can assume for the year in this case you can assume the shunt capacitor DC is connected to this feeder connected to this feeder. Now this case, what are the now see these different types of these capacitor banks are different capacitor banks are. Yes, see this different capacitor bank. You have one capacitor bank, two capacitor banks, three capacitor bank, four and five water different types of capacitor banks. This is the circuit breaker. This is the transfer. This is the transfer. So these are the switches to open and close. Yes, it is capacitors. Okay, capacitors. These are the capacitors. These are the switches. Yes, these are the switches to connect the connect or disconnect the capacitor banks from the system. So why these capacitor banks are used here? So many cases. The first case to improve the power quality, the loads. Second one to meet the demands. In our households also, we are using these capacitors or batteries to maintain the power, continuous power. Okay, so then what is another case here? In this, they discussed here to support the voltage during high load periods, to supporting, to injecting some voltages, whether the loads are increasing time to time. So then when here we are talking about the capacitors, there are some different conditions are arised into the system, because these capacitors are not continuously giving the voltage to this feeder. Okay, so whether you need this capacitor on the time only, the switches are closed, otherwise the switches are open. So this opening, nothing but this operating of this capacitor, they can maintain some intelligence techniques in internally at the load location side or from the external side also. So now see this capacitors at the same time, this capacitors is operating independently. Okay, this capacitors is operating independently. That means these capacitors are no way connection, no way concerned about the supplies, supplying generator. So whether the generating is working continuously or not, whether this generating is producing the power, standard power or all other things, it will not work about this. These capacitors are working independently. Here in this case, remember, we are assuming the capacitors to meet the load demand. So irrespective of the source. Okay. So here there is a problem in this case. There is a problem in this case. Irrespective of the source side, we are operating this. There is a problem. Okay. So now see this a 2 to 3% increase in the load voltage. Voltage is common when the capacitor bank is enhanced. Yes, whenever this capacitor is switched to the feeder, so on the time 2 to 3%, 2% to the 3% voltage variation is common. Voltage increasing, voltage is increasing, voltage is increasing. Okay, so now the case here, the case here. What is the main thing here? As I said, these capacitor banks are operating, as I said, these capacitor banks are operating independent of the source, nothing but generator. So what will happen here? The generator control attempt to maintain a constant reactive power output until it comes against one of these limits. Here, what is the meaning of this one? Please wait for the second. For the delay, yes, let's see this. Now see this. Why this case means here? Here you can observe that a transformer, sorry, a generator. How the generator is maintain this reactive or all other things to maintain the constants. So an exciter is used. Excited, excited. Why you are talking about this reactive power and all other things? So because of this capacitance effect, maybe leads to some problem in this one. So that's why a generator is to maintain the an exciter to give the constant excitation to the generator to produce the power and all. Here you can see this. That is the point here. So there can be some conditions that. So whenever here see this case, whenever the capacitance, the total reactive power output of the generator and capacitor is too great, resulting high voltages. This is particularly when the capacitors are switched by the clock or by the current. So, so in this case, you know that what is the main equipment in the power system? As generator. So we need to protect the generator from this case. Yes, the capacitor and the generators, they can take the three precautions like this. The generator control senses the over voltages at the terminals. Yes, yes, generator is also know that whether the load is increasing or decreasing. Based on that, there are some excitation techniques as well as some speed control techniques that has happened into the system. So based on that one, generator is operated. Okay, so generator is aware of the load side voltages also. Nothing but okay, or voltages also. That is the first case. What is the second case? Generator reaches this voltage limit. The reactive power flows back into the machine. When it reaches to a certain level, generator production interrupt to this mark. You know that because of capacitor, adding more capacitors that may leads to the increasing of the voltages. There are over voltage cases that may leads to the some malfunction. Yes, yes. What is third one? DC. DC means a capacitor that does not produce reactive power supply trips on over voltages. Okay. Here, see this a simple example here. Whether these capacitors are charging. Once again, this use this power from this faders only. A discharging case means here they can discharge the some voltage to this fader when there is a increase in the load demand. So here our intention is that whether you are adding this shunt capacitance to these lines, so that may leads to the over voltages to the to this feeder. then what percentage of that over voltage is accepted? 2 to 3% of that over voltage is accepted. Whether you connected the shunt capacitors to meet the load demands, on that time the 2 to 3% of increasing of that load voltage is accepted. Otherwise the generator protection equipment is activated. Why? Because this whatever you are consider this DGs, nothing but these shunt capacitors are nowhere interaction with the source side. They are independently operated. They are independently connected to this feeder. So that's why a protection is taken from the generator side. So this may leads to the generator may generator malpractice, some fault cases, some other things. So that's why generated protection scheme is very much important for whether we are using this capacitors to improve the drive the loads. These are the three cases to protect the generators. Okay. Yeah. Okay. Thank you for joining this class. Next class, we may going to see the very much important topic, transformer connections. Yes, you have the transformer, different types of the transformer connection, star delta, delta to star connections, then with the ground, then without ground cases, different cases are there. So based on the transformer connection, we are using transformer. So transform, this is the transform. Then this is the transformer connections. Based on these transformer connections, how to eliminate the problems while interfacing this DC through the transformers. And based on the different types of connections, what are the different operating functions we may arise in the system, and other things we may discuss in the next class. Okay, thank you for joining this class. Thank you very much.